Good afternoon, ladies and gentlemen, and welcome to the WGO session. And I'll explain WGO to a couple of you who've said, what is WGO? But I'd like to start by thanking the organisers of this terrific World Congress, Ahmed and Harry, who invited us to give a session representing the World Gastroenterology Organisation. We looked at the program, which is an excellent program, and so we thought, and I communicated with Ahmed, who was looking after the scientific program, and I said, look, I think what the people need to hear is something quite different from the program, but also something that's critically important to all of us. And he said, great idea, what do you want to talk about? And the answer was climate change. Now, a lot of you will glaze over and yawn, but don't, because we've got a lot of really important, impactful and detailed information that you need to hear. My name is Geoffrey Metz and I'm President of the World Gastroenterology Organisation, but I also live in Melbourne, Australia, not Melbourne, Florida, and I'm happy to chair this session. I'm joined on the stage by the moderator, Christopher Leung, who's a physician, gastroenterologist, in Melbourne and also at the University of Melbourne, and Chris is involved in research and advocacy at the College of Physicians and also the GE Society of Australia through the Sustainability Network here in Australia. The first speaker is a friend of mine from London who I think is, I'm told is, and I'm sure he is, the most important doctor working in climate change around the world. And that's a pretty big label to have on your head. But Professor Hugh Montgomery is Professor of Intensive Care Medicine at the University College London. He is founder and inaugural editor of the Lancet Countdown, which is a large group that research and publish throughout the year. They put out an annual report on climate change, the impacts on health, and he reports to the Intergovernmental Panel on Climate Change, IPCC, which you'll all have read about, and he also reports to the United Nations. And he was joined in creating the Lancet Countdown by another friend, Anthony Costello, who is Professor of Paediatrics and was head of Paediatrics at the United Nations before he left Geneva and went back to London, where he joined with Hugh to create the Lancet Countdown. I give you that preamble because they really are an extremely influential, knowledgeable group who have hundreds of people who report to them, and they put, those people are basically doctors, scientists, journalists, politicians, a whole range of people, including statisticians, epidemiologists, and they put out their reports regularly. And so, without further ado, Hugh doesn't fly because of climate change. He travels within the UK and within Europe by train and walking, and he has sent us a 20-minute talk which he's entitled The Unavoidable Truth About Climate Change. If we could start Hugh's video, please.
Well, hello, my name's Hugh Montgomery. I'm Professor of Intensive Care Medicine at University College London, where I chair the 47-country Lancet Countdown on Health and Climate Change. And I'm going to talk to you about the unavoidable truth about climate change. Because we've avoided that truth, we've covered our eyes, we've covered our ears, and we've spoken not at all about this issue, because life is just too comfortable for us to face it head on. But now is the time for us to face up to that truth. We were first warned 165 years ago or more by John Tyndall, who told us that gases such as carbon dioxide would be acting as greenhouse gases, letting shortwave radiation through and trapping longwave radiation. And he warned that burning increasing quantities of fossil fuels from the Industrial Revolution onwards could potentially cook our planet. But we took no notice. We took no notice when Henry Kissinger warned us 50 years ago that we were already seeing those climate changes throughout the world and told us to act, but we didn't. 36 years ago, the scientists of the world met at the Toronto conference in 1988 and warned us that these impacts were already threatening international security and causing global harm. They said we had to peak emissions and then cut them quickly, by 2025 by at least a fifth. But we took no notice at all then, and it's now 19 years later. Indeed, emissions are continuing to rise. On the x-axis, the year since 1850, when Tyndall first warned us, and on the y-axis, the gigatons. That's billions of tons, thousands of millions of tons that we're releasing every year. And you can see that quantity is going ever upwards. Indeed, we've taken no notice of Kissinger, Toronto, and indeed the first conference of the parties' negotiations. Emissions have continued to rise. Last year, if you look at all the greenhouse gases as CO2 equivalents of warming, we released 53.8 billion tonnes of CO2 equivalent last year alone. And it lasts a long time in our atmosphere. A fifth will still be cooking our planet in 33,000 years' time, and 7% will be boiling our planet in 100,000 years' time. So we have to stop emitting right now. Indeed, if you keep putting that large quantity of gas into an atmosphere and it lasts a long time, the concentration will rise. Here, the graph in Hawaii from 1960 up to present day, and you can see that concentrations have continued to climb at an ever-increasing rate. Indeed, this year alone, we pumped through 427 parts per million, the largest two-year jump on record. And that's trapping a lot of energy, letting the shortwave radiation in, trapping the long-wave radiation. How much? Well, measured in Hiroshima bombs, around 8 Hiroshima bombs worth of energy every single second being added to our atmosphere. And that's driving up global surface temperatures. On the x-axis there from January through to December, on the y-axis global surface temperature averages. Each wiggly line, the grey ones, is a year, and every year it's been getting hotter and hotter, moving further up the graph. Last year is the orange line, this sudden and dramatic departure, and the red line is this year, and you can see still accelerating away. If you look at the anomalies compared to pre-industrial, you'll see that these averages are indeed averages. Some areas are very much hotter. You'll see some areas are 12 Celsius above pre-industrial levels. Sea surface temperatures are also rising. Same sort of graph, each wiggly grey line going further and further up this chart until this massive departure last year in the orange line. And indeed this year, again, another major departure, heading ever hotter. And again, if you look at sea surface temperature anomalies, you'll see again that temperatures are not evenly distributed. Some areas of the ocean this month have been 3 Celsius or more above normal. This ocean heating is dramatic, and it goes down to a depth of at least 2 vertical kilometres. If we look at the energy added every year, you'll see last year we were approaching 280 zetajoules of energy. Well, how much is that? Well, it's the energy equivalent of taking 1 trillion Olympic swimming pools from freezing point to boiling point. A huge amount of energy added last year alone. And this is causing Arctic sea ice to decline. It's causing Antarctic sea ice extent also to fall. Each line being an extent, each line dropping with each year. And you'll see again this big departure last year. Indeed, if we look at the Greenland ice shelf alone, we're losing around 5,000 square kilometres since 1985, over 1,000 billion tonnes of ice. And we're losing colossal volumes now, around 30 million tonnes an hour. We're seeing it on land too. In mainland Europe, these are the Swiss glaciers, and in the 2 years to last summer, the Swiss glaciers lost over 10% of their total volume. And remember, these don't recover in geological timescales. If you melt land ice into the oceans and you expand those oceans thermally, sea levels will rise, and you'll see that they are, and that rate of rise is also getting ever steeper. Indeed, the last time we breached 420 parts per million, remember we're now at 427, sea levels were 58 metres higher than they are now. So that's what we're committed to, and it could happen, as I'm about to show you, very quickly indeed. If you add energy to an atmosphere, you get weather. The more energy you add, the more extreme weather you get, and the more extreme weather events you get. And just as you predict, the numbers of extreme weather events are going up ever more steeply. And we can remind ourselves of just how normal this sort of extreme has become. This was 2020 in the Northern Hemisphere winter with the fires in Australia, but also in Indonesia, Siberia, Angola, Congo, Amazon, and California. By 2021, the fires were in Canada and Colorado, but also throughout Europe. In the summer of 2021, Australia was flooding. Belgian-German border, top left, was flooding. Germany, top right, flooding. The London floods, 3 of them in the August of that year. The bottom left, New York subway, that iconic picture, but also floods, killing tens of thousands in China, there in the middle, British Columbia and Malaysia. By 2022, we had extreme heat waves in Pakistan and India. We had record temperatures across Europe and in the United Kingdom, as well as record temperatures in China, Japan, and Korea. But the same year, we were seeing the highest density rainfall ever recorded in southern Africa in 2022 and KwaZulu-Natal, in Valencia in Spain in 2022. The same year that Pakistan was boiling and incinerating with high temperatures, a third of it then was underwater of its land surface area. Venezuela was flooding, Nigeria with over 500,000 displaced, and the highest storm surges ever recorded in Florida. By January of last year, this was the picture on January the 1st, normally when it would be 10 Celsius, quite chilly, and here are people in 25 Celsius playing beach volleyball. By March of that year, Switzerland and France and Italy were facing lack of snow and lack of rainfall with drought. And by the summer, Canada was ablaze again with these iconic pictures from New York as the smoke drifted down to envelop the city. By July, record temperatures again in Korea, Japan and China, in the United States and throughout Europe, followed by Hawaii incinerating, Canada, China and more. Indeed, by the September of that year, normally the winter temperatures in South America, these were exceeding normal summer temperatures in South America. And remember, this year already has been no different. Chile was ablaze with high temperatures in February, followed by California getting severe flooding and Los Angeles County affecting 38 million people. The Swiss ski resorts were left without snow. The reservoirs in Catalonia in Spain were down to 16% of their normal volume, and that was in the middle of winter. Texas had its biggest fire, or second biggest fire ever recorded. Dubai had 2 years of rainfall in 18 hours, and that was followed again by the same event only a few weeks later. Flooding was killing or threatening millions of people in China. This was followed by India in June of this year, temperatures breaching 50 Celsius, air conditioning units packing up, and many, indeed 40,000 at that point, with heat stroke. By June the 21st, record temperatures were hitting the United States. The Hajj pilgrimage, we've now lost nearly 1,200 people dead today as a result of this heat wave there. We've had extreme weather ravaging Europe in the end of June and early July. And we've had these fires in New Mexico. Today, as I'm recording this, which is the 30th of June, Arctic fires are tearing through Russia's far north. All of which threatens us enormously because this desiccation of the land, the melt, the extreme weather events is threatening our very ecosystems. Remember that we've already got 8 species now becoming extinct. We've lost 72% of vertebrates on the planet since 1970. And as this paper in Science was pointing out, species losses equivalent to some of the Earth's previous mass extinction events will be committed to by the end of the century. Remember, 94% of life in the oceans died in the Permian mass extinction. And we've done all of this with a global average surface temperature rise from pre-industrial of only 1.43 Celsius, which is clearly catastrophically dangerous. But remember, these gases remain in the atmosphere a very long time and will continue to cook us. Indeed, the Intergovernmental Panel on Climate Change warned us 2 years ago that we had to act for our own survival, pointing out that any further delay in global concerted action would mean we'd miss a brief and rapidly closing window to secure a livable future. That's one where you or your children might survive. But we've done nothing. Nothing at all. Indeed, if you look at what humanity burned in 2023, it was this. Worse still, we triggered a series of positive feedback loops that are accelerating heating. As you melt snow and ice, you lose what is known as the surface albedo effect, in which the snow and ice reflect light back into space. As you melt that snow and ice, there's more dark ocean to absorb the heat. And indeed, this effect has doubled the rate of Earth's energy gain in only the last 14 years. And in June of this year, a paper was published in Nature Geoscience showing that things are worse even than that, because there's surface melt, pools of water and slush appearing on the Antarctic ice shelves, which of course are oceanic, and which pin the glaciers which are on land. We now know from that analysis of 57 ice shelves that this pooling of water itself is meaning that the ice shelves are reflecting less heat back. In fact, there's 2.5 or nearly 3 times more greater snowmelt than we projected, threatening ice sheet stability. And if they do melt at this sort of rate, it threatens glacial stability, which will rush into the oceans, accelerating sea level rise. The fires are producing carbon dioxide, which is itself a greenhouse gas causing more heating. How much? Well, if you think of just the Canadian fires of just last summer, they alone added 6% to total anthropogenic greenhouse gas emissions. The fires are also producing carbon monoxide, which mops up hydroxyl radicals, which would normally clear methane. Methane is 83 times as powerful a greenhouse gas as is CO2 in its first 20 years. And we're releasing a lot of that methane too, from heating rocks, which is leading to release of melting clathrates, and also methane hydrates in frozen tundra, as well as release of methane from fermenting wetlands. Methane levels have been rising because methane is natural gas, as it's called, used by the fossil fuel industry. And that had reached an equilibrium by the middle part, about 10 years ago, middle part of the 2010s. But because of these positive feedback loops, those concentrations are now accelerating at an ever-increasing rate. The evaporation of water with storms is injecting water vapour 19 kilometres up into our atmosphere, where it acts as a greenhouse gas. And we're now finding that the rainforests, which were normally net sequesters of CO2, are now net emitters of CO2. We're also warming the soils, which is causing it to respire and release more carbon dioxide. So multiple positive feedback loops accelerating heating. But worse still, weather will change in sudden binary state changes. One of these are known as Dansgaard-Oeschger events, and we've already pointed out that average surface temperatures are only averages. The poles, indeed, are warming 4 times quicker than the global average, and this can accelerate in these DO events as they're known. There's one in the middle there at 38,000 years when temperatures jump by more than 10 Celsius in only a matter of a few years. This paper was predicting that we had reached one of those or triggered one of those events now. But look at the scale. 35 Celsius increase in temperatures at the poles in a very short time frame. And you'd hope that we hadn't triggered this, but the data would say that we have, because this was March the 21st, 2022, when temperatures in the Antarctic were 40 Celsius above normal and the Arctic 30 Celsius above normal. Bad enough if the temperatures the following day hadn't risen further in the Antarctic to 47 Celsius above normal. And indeed, in June of that year, average surface temperatures in the Arctic Circle were 32.5 Celsius, plus 32.5 Celsius, when they would normally be only 13. We're seeing these sudden surges in temperature too with instability. In Greenland of that year, sudden ice melt, the grey shading being previous years and the red being that year, with the first week of September seeing a rise of 20 Celsius above normal, melting 20 billion tonnes of ice in one weekend. That's 7% of the annual total in less than 2 days. Bad enough too if that wasn't the second year in a row that had happened. Bad enough if it didn't happen again last year. So this is becoming a regular event. The trouble with this is if you breach even 1.7 to 2.3 Celsius, even transiently, you trigger abrupt ice sheet loss that is irreversible, leading to very sudden and dramatic increases in sea level rise. And remember, there are other effects that are causing this too, such as that increase in melt on the ice of which I spoke earlier. The ocean currents are going to collapse. This is the Atlantic meridional overturn circulation drawing in warm water from the Pacific to the right, coming up past the western coast of Great Britain in the top left there. We know that collapse would cause devastating impacts on global weather systems, and we also know from these 2 papers that we're now at a point close to a critical transition. One of those papers suggesting this becomes statistically possible by 2028, so that's only 4 years away. The jet stream is a high-altitude river of water-laden air at the junction between the colder Arctic air and the warmer southern air, driven by the Coriolis effect of the Earth's rotation. As the Arctic is warming much more quickly than the southern air, that jet stream is moving north, depriving the whole of the Iberian Peninsula of the rainfall it needs. That's what's causing the droughts that you've seen in Portugal and Spain, and that reduction in reservoir volume of which we've spoken. But it's also dumping that rainfall on Northern Europe. Indeed, in Great Britain, we lost 10 to 12% of our agricultural economy this year due to intense rainfall. So these extreme weather events will combine too with unlivable climates, leading to starvation. And that, plus economic collapse, leads to migration and conflict. The economic collapse is very real. Indeed, if we look at that and the unsurvivable conditions, both threaten us right now. This paper in PNAS from 4 years ago saying that in the next few decades, the next 3 decades indeed, 18% of the world's surface area currently occupied by humans will be uninhabitable. They'll have temperatures more than the Sahara Desert, leading to around 3 billion people outside of survivable conditions. They'll have to die or move. And to that, you can add the 2/3 of a billion who would then be under the high tide mark. That's a half of the world's population migrating or dying. On top of that is the economic collapse. The Pakistan flooding, of which I spoke just recently in my earlier part of the talk, led to massive economic impacts. Over 2% of its GDP was lost. In the same summer, the United States droughts in the plains led to losses of 9.4 billion to their economy. And by the end of 2023, by the August, there'd been 15 extreme weather events due to climate change in North America, each costing more than $1 billion. In Europe of 2023, the summer droughts led to a loss of 13.4 billion euros to the economy. And the Florida flooding later that year cost the US economy $18 to $20 billion in just one go. Indeed, these costs are rising globally. We're losing around $4,500 every second to the world economy. And those costs have already reached over 4.3 trillion and rising. They're going to get worse too. Lloyd's of London saying we're looking potentially at 5 trillion losses within the next 5 years to the global economy, with a 1 in 300 chance of a single extreme weather event in just one country, taking $17.6 trillion, that's a fifth of the global economy out, perhaps within a week. That would make the economic collapse of 2008-9 or the COVID impacts minuscule by comparison. Indeed, if you look at just static temperature rises, we're committed within the next few decades to losing 20% of the global economy, and it could be up to a third, 38 trillion per year by 2050. That's 26 years from now. Indeed, the Institute and Faculty of Actuaries and Insurers warned that without significant action, our economy may not exist at all. They also point out that it's too late to do this slowly. We can't do it incrementally. We now have to engage in transformational change. And this is the truth that you need to hear. You and I must act. It's worse still than that, though, because we know that we'd underestimated global heating by 50 to 100% for various reasons. And as Jim Hansen of NASA Goddard points out, the idea that 1.5 degrees could be reached is as dead as a doornail. And we're now heading towards 10 Celsius. And let me remind you of the catastrophic effects we're seeing with 1.43, which threaten the entire ecosystem and our own survival. So you have a choice. You can continue to pretend that you've not heard this talk, cover your eyes, the last slide, cover your ears, refuse to talk about it, and do nothing. Or you can do the right thing for you and for your children, and take action. And that is what you must do. So right now, you need to commit in your heart to taking action. You then need to perform those acts, and you need to lead others to do the same. You have to do those things today. You cannot go home and sit in front of your television set tonight and do nothing. So what are the actions? Well, emissions are grouped into scopes. Scope 1, the greenhouse gases you emit from burning fossil fuels yourself, so coal in a fireplace, petrol in a car, gas in a boiler at home. It is expensive, but you must stop burning fossil fuels in your cars. You must get rid of your gas boilers and electrify your homes, put in air source or ground source heat pumps, or move to electric heating. Yes, it's expensive, but that is the price of survival. Scope 2 are the emissions that come from the power you use in your homes or places of work. That's straightforward. You must move to a power supplier that is 100% renewable. In Britain, there are many choices. Otherwise, you must put in your own power generation, solar photovoltaic systems, for instance, or solar hot water panels. And finally, we must think about the emissions in Scope 3 from the actions we take or the things we procure to happen. All our travel, personal and professional, and to conferences and so forth, we need to not go online, or we need to walk and cycle where we can. And if we have to get there and it's a longer distance, we must use public transport. And if we can't use public transport, we must share cars, and we must avoid flying at all costs because of its huge carbon cost. Food is a very important thing. It sounds as if it's not, but it is. The food supply chain represents a third of global greenhouse gas emissions, and a lot of that comes from pasteurization of milk, refrigeration of dairy products, from cows belching methane, from chopping down rainforests to feed or graze those cows, from processing the food, from transporting the food when it's not seasonal. Quite simply, we must all move to a plant-based diet, one that is largely composed of plants, and ideally those plants should be local and seasonal. And we have to do that at home, and we have to do that at our conferences. We need to change where we bank, because many of our banks are investing the money we have there in fossil fuel extraction. So we are financing our own extinction. So move your bank account tonight to a bank that does not invest. In Britain, that would be the Cooperative or Nationwide Building Society, or to an online bank such as Monzo. And we need to move our investments. If you have shares, or your institution or organisation does, they must move them out of fossil fuel extraction. And then we must think about everything we buy. Do we need to buy products at all? If we do, let's buy them from organisations that are committed to decarbonisation. And we have to do that at home, but we also have to make sure that our hospitals and healthcare institutions and universities also clump together and write this into their contracts and do the same. If we don't act, we are the villains of the piece. If we do, we can be heroes forever and ever, as David Bowie say. If you wish to get some more information, we've founded a non-profit in Great Britain to take action. We can help support you in doing that, or indeed you can form your own organisations and we can provide you with the information. But I've told you the truth now. You can't not hear the truth. You've heard it. You now must decide, do you care for your own life? Do you care if your children will survive? And if the answer to those questions is yes, you must act now. Thanks very much indeed for listening.
Thank you very much indeed for listening, and I've already thanked Hugh when he sent me that video a couple of months ago. It's pretty dramatic hearing. As he has said, he's telling the truth. And the next two talks, I'm going to talk next briefly, and then a talk about gastroenterology and surgery from our colleague Daniel Snyder from London, is really, I've put it together because when people listen to Hugh, they think the end of the world is upon us, we might as well give up now. He is a total pessimist because he privately says to you, I don't think anyone's going to make a change. I think in 50 years from now, there will be a total world war, that people will be migrating to where they can theoretically live. There won't be many places left where you can live. You might have a tropical resort in the north of Canada, but there won't be much left. And that's a bit nihilistic. So what I'm going to do from the next couple of talks, myself and Daniel, is to see what we must do but also can do in a realistic way. Because if you listen to the facts, and Hugh isn't taking those figures from the back of his head. Each of his slides had a quote from it. It was scientific journals, it was Nature, it was Science, it was authoritative groups, even the Institute of Actuaries talking about the cost of insurance. I don't know if any of you have received your insurance quotes for this year, but mine has gone up 75%. And that's the effect of the bushfires and floods that we've had in Australia recently. And they'll get worse. So I'll leave it there and thank Hugh on your behalf for his dramatic but important talk. Thank you.
Yeah, thanks. So as Jeff said, my name's Chris. I do have a conflict to declare. I'm Deputy Chair of the Doctors for the Environment Australia. We recently launched our fossil fuels, a health hazard, to lobby the government to not develop any further coal, oil or gas in the country. And we launched that recently. And you know you're sort of making a dent when you get a full-page editorial in The Australian touting why we should just be doctors. But I would say as doctors we have the responsibility to advocate. So who feels a little bit depressed from, as Jeff said, feels a little bit depressed from what Hugh has just said. But I want to just echo what Jeff has said. There really is a hope. If we achieve net zero, which is why net zero is so important, then temperatures stop going up within 3 to 5 years. And then within 25 years, half the CO2 equivalents will fall out of our atmosphere. So as quickly as it has gone up, it can as quickly go down. Within our lifetime, we can turn this around, we can change things, which is why you must listen to Jeff speak now. Jeff has been awarded an officer in the General Division of the Order of Australia for his distinguished service to medicine, medical education, both nationally and internationally. He's the president of the World Gastro Organisation and has held other positions in the WGO, including chair of the scientific committee and member of the Train-the-Trainer committee. He's absolutely passionate about climate action. He has academic titles at the University of Melbourne and Monash University, was Director of Medical Education and Dean of Medicine at Epworth Healthcare and Alfred Hospital, and former President of the Royal Australasian College of Physicians, member of GISA and the International Society of Internal Medicine. So a big round of applause for Jeffrey.
Thank you very much indeed, Chris. And I think I'm up. Yes, I am up there. What I wanted to talk about was changing the world through education and advocacy, because I think, in fact, as I said, Hugh at times is depressive, perhaps clinically, but certainly factually. And so I have always come from a glass half full family, and I think it's important to say, what can we fix? What can we do? Let's make sure the world is still here in 150 years' time, which is being questioned. I've got there no disclosures. I have one disclosure, which is, you possibly saw me get up just then. I had a conflict with a tram recently. I've got 2 broken ribs and my right Achilles tendon is shredded. And so I'm supposed to have a moon boot on as we speak, but I'll put it back on after this talk. The things I'm going to be talking about are the following headings. Is climate change occurring? Well, I think Hugh has convinced us, so I won't dwell on that. Is it cyclical or anthropogenic? That is, caused by people, not just cyclical. What are we witnessing? How long have the scientists been warning us? I'll cover those 4 topics in just a few minutes. And the important points I want to make are, why has it taken the world so long to respond? Why has it taken so long for doctors to respond? And what should we all be doing right now? Sorry. So just the terminology briefly. You've read a lot about greenhouse gases. CO2 is the marker, but as Hugh pointed out, methane, nitrous oxide, a lot of the anaesthetic gases we use all contribute to greenhouse gases. They cause global warming, that's undisputed. That leads to climate change, which the scientists have been telling us for the last 100 or more years. And the 4th one I wanted to talk about was sustainability, because what we have to do is move from the discussion about climate change to what we need to do to sustain the planet. So that'll be towards the latter part. Now, you've seen this from Hugh, and I think the important points to make throughout the last 800,000 years, the CO2 parts per million in the atmosphere have varied most of the time between about 150 parts per million and 300 parts per million. And when they go down, there's an ice age, and when they go up, the world is warm. That's data that appeared in Nature. It's well researched, it's based on carbon dating, and you can trace that through the scientific examinations of glaciers, etc. At the start of the Industrial Revolution, the carbon dioxide concentration was 280 parts per million. And over the subsequent 100 years, it's gone through the 300 barrier, and it's kept going up through 350, 400, and it was 409.8 parts per million on average in 2019. And as Hugh pointed out, it's gone from 2019, 409, up to 427 right now. So the CO2 concentration is rising exponentially, and it's that leads then to the climate change action. The global temperature you've been reading about, and as Hugh pointed out, it's about 1.4 degrees. That says 1, but that says -0.4, so we're on the same scale. About 1.4 degrees above where we were earlier in the Industrial Revolution. The first 50 years or so of the Industrial Revolution, it didn't rise much. It took a lot of other activities, particularly the development of the car, the development of aeroplanes, and all the other travel things that we do, burning down huge areas of forest to put up palm plantations and other farming activities, increasing the amount of animals that are being farmed, all sitting there burping and farting CH4, all contributing so that the rise since the turn of the 1900s has gone up 1.43. Now, the scientists predicted it all, and they said in advance, they said 100 years ago, small rises in global temperatures will have profound effects on heat waves, droughts, extreme weather events and floods, what we call bushfires and the Northern Hemisphere call wildfires will increase dramatically, and they have. They will add further to greenhouse gas increases. That will lead to ice caps melting, and that will lead to sea levels rising. Coastal lands submerged. You've read a lot about the islands around the idyllic islands around the South Pacific, which are being submerged by the rising sea. But it's also happening everywhere else in the world, around the Australian borders, the ocean borders, areas which are going to be submerged very soon, and some already have been. Some parts of the world much more dramatically. Bangladesh has lost hundreds of square miles of coastal arable land. It's all under the sea now, and it's increasing. And so these things were predicted by the scientists. They are happening. They also talked about the importance of water and food security. Now, people say to me, what's that mean? It means that we can produce food that's nourishing. It means that we can drink water that's not going to make us sicker. And the security of food and water is declining. And this all has massive effects on our health. So we're witnessing all of those things, long periods of drought, the highest temperatures ever recorded. And you'll remember reading the papers in the last couple of years that each year for the last 3 years has been the hottest ever recorded in the world. So we reached a peak in 2021, but then went higher again in 22 and higher again in 23. You've all read about the wildfires, the worst that have ever been experienced, and in places that never had wildfires before, like Canada, which had pristine forests burnt completely in the last 2 years, as well as right through Europe and Siberia, believe it or not. 1 in 100 year flood levels. We always read about if there was a flood, oh, that's a 1 in 100 year event. But they're happening every year now. And it's happening all around the world. Now, why has the world taken so long to respond? And I've got a few theories here which I'd share with you. The first is that for a long period of time, lobbyists and opinion leaders were saying, what would the scientists know? It's all speculation, it's all hypothesis, they don't know what they're talking about. Lobbyists, I would remind you, are people who are paid to say a particular point of view. And lobbyists move to Washington, or they move to Canberra, or they move to London, and they go to speak to politicians because they're paid by someone to do that. I need say no more. Opinion leaders are usually people who like to see their photos in the paper or their face on TV. They usually don't know nearly as much as the people who do know, the scientists and ourselves, about the topic they're talking about. Politicians denying the evidence. I've thought about this for a very long time. Politicians are smart people, they're not stupid. But politicians, and I'm aware of the fact that your president is in the audience, and Harry Frydenberg is the father of a very, very influential politician. Now, what I would say is that politicians are very smart people, but they see their role as supporting employment, supporting industry, and supporting the economy of the country. And so if you said to a politician, shut all the coal mines tomorrow, they'd say, but there'd be 100,000 people out of work. What are we going to do about that? Stop drilling for oil, but there'll be another 100,000 people out of work. So politicians are aware of the fact that they have a responsibility to the people where they serve. And so it's not enough to say, to walk into Canberra and say, this is a piece of coal, don't worry, it won't hurt you. It was said, as some of you will remember, in Canberra about 10 years ago. It's why they say it. They're protecting industry. Beyond that, you'd say, well, are there other people who are trying to influence the debate? You may have heard of a group called the Global Climate Coalition. The GCC was set up in 1989. It was formed by the oil industry, Shell, BP, all the big American oil companies and others from the Middle East. They put in hundreds of millions of dollars to create the GCC. And it included steel industry, included the rail industry and the auto industry. And they put money into what they called changing the narrative. We're going to tell the politicians, we're going to tell the journalists, and we're going to tell the people of the world that this is all rubbish. Fossil fuels are not doing you any harm, gas is not doing you any harm, and they embarked on the campaign which lasted from 1989 to 2001. And over that period of time, they became the opinion leaders. They employed very eloquent speakers who were paid money to give these lectures that fossil fuels are no harm. 2001 it closed down because in 1995, 96, 97, 98, the oil companies and the auto companies progressively dropped out of the GCC saying, we can't be in this group any longer, we're afraid they're telling lies. And eventually in 2001, it collapsed because they all agreed that they were telling lies. But they spent those 12 years lobbying politicians against reducing fossil fuel use. Why did it take doctors so long? I mean, we are seen as an honest group. We are seen as a trusted profession. So why didn't we speak earlier and louder? And I put it to you that there are reasons for that. The scientists made their case over the last 150 years, but we are traditionally conservative. We don't rush in and say, oh, that piece of new evidence must be correct. We watch and we wait and we see if it's been shown to be correct. So there was initial uncertainty about whether 1.5 degrees rise in temperature would have the devastating effect on weather, would have the devastating effect on the melting of the ice caps, would have the devastating effects of rising sea levels, etc. But we're now seeing it happen. And so the doctors, through DEA and similar groups all around the world, are saying we can't ignore the facts. It's having an effect on food production, water security, habitat destruction, the biodiversity of the world, and health generally. And I'll show you how that's happening. You've all seen these photos. This is Eastern Victoria in 2000. This is Brisbane, the same year when upstream from the Brisbane River, they had a year's worth of rain in 3 days. Never seen before, never heard of, never speculated that you could have such heavy rain. And this is northern Canada, where they've never had bushfires before. And this is northern Canada just last year. So what happened in Australia? Well, we've talked about the bushfires. 2020 burnt out an area the size of Portugal. The whole of Portugal burnt in Australia. So it was over 90,000 square kilometres was completely burnt out. Never happened before. The rain in New South Wales and Queensland, the heaviest ever recorded. But before that, 20 years of drought in those areas. The coastal erosion is impacting us now, hadn't before, and diseases are spreading. Dengue fever and Ross River, which hadn't ever come south of the Queensland border, it's gone into New South Wales, it's gone to Victoria now, and it's heading south because we're getting warmer. Now you might say, but hang on, last summer was not a hot summer. There's a very big difference between the weather and the climate. And weather goes up and down each day, but climate is incrementally getting worse. Just to go through this briefly, if we look at the centre of the bullseye, CO2 rising causes rising temperatures, causing more extreme weather events, and the extreme is the important thing we've observed. The worst winds we've ever had in Victoria just a week ago, and same in Tasmania, and rising sea levels. All of these things create climate change. So severe weather has such as cyclones, severe rainfall, severe droughts, severe winds, cause injuries, fatalities, and these things make people upset and scared and mental health impacts, and we're seeing that. Air pollution affects asthma and cardiovascular disease. There's a change in vector ecology which has been shown to be occurring, spreading all of these diseases into areas that haven't been seeing these diseases previously. Increasing allergens in the air affecting respiratory disease. And I'm coming to gastroenterology now. Because of the impact on water quality, we're seeing a lot more infectious diseases. Because of water and food insecurity, we're seeing the effect of malnutrition and diarrheal diseases and liver diseases as well. Should have put on that slide. Environmental degradation is what Hugh was talking about at the end, which is that all of these things are making increasing areas of the world uninhabitable. We're seeing people migrating from North Africa, the Middle East, going north and going west from where they are. And that creates civil conflict, mental health impacts, and also potentially war, as Hugh was pointing out. So we can't ignore it. At the WGO, we had a survey in 2021, and we are a federation of 119 member societies throughout the world. So the GE Society of Australia and our equivalent societies in Singapore, right through Asia, right through Africa, right through North and South America and Europe. So we represent 66,500 gastroenterologists everywhere in the world. We surveyed the presidents of each of those 119 societies, and 48% of them replied, and the responses were really very interesting. The question one, I won't go through all 12 questions, but just the interesting ones. Some people have described climate change as a crisis. Can you tell us how you personally feel? Please move the slider so it shows your opinion from 0, I don't think it is occurring at all, up to 100, I think it's a major crisis. And what they reported, 86% of them said they did believe in climate change, and the majority of those said it's a crisis. Back here, interestingly, if we recognise that there are 119 societies represented right across Africa and Asia and other parts of the world, a number of them didn't believe in climate change, and this was only 3 years ago. Second question, if you assume that climate change is happening, do you think it's caused by human activity completely, by a mixture of human activity and cyclical activity, or caused, mostly, or 50-50 by human activity and cyclical changes? And what they said was, the majority got it right, that it's more caused by human activity than by cyclical activity. Question 3. We'd now like to know how engaged you personally are on the issue. And to summarise this slide, what the majority was saying was, have you made any changes to your personal life, such as decreasing driving? The majority hadn't made any change. Have you made any changes in your professional life, such as decreasing energy use in your room in your hospital? The majority said either it's not feasible to make changes, no, we haven't made any changes, or maybe we will make some changes. But it was the minority who said that they were getting involved. And do you plan to make changes? And again, the majority was saying no. 4, health professionals have not been very engaged in the issue of climate change. Why do you think this is so? And the responses was just an open page for them to respond. And they were basically saying either we don't think climate change has a major impact on our medical practice, or there's lack of information, we don't know what we should be doing, or I'm too busy, or it's really a problem for industry, not for the medical profession. They had lots of reasons why they won't do anything about it. But then we asked them, question 12, the last one I'll quote, do you have any thoughts, comments, suggestions about what you'd share with us? Is there anything you'd like us to do? And this is the area that they responded maximally. And we had very long letters, not just filling the box, saying things like, we're not aware of what the issues are, it's great that you're talking about it, we like your initiative, we'd like to take part, can you send us slides or other educational material, please? Please give us strategies, please give us practical advice. So they were really saying, if it's true, tell us what we should be doing, because they weren't sure what to do. So we took those responses as saying we need to educate and advocate, and that's the talk that I'm addressing. So internationally, doctors need to be educated as to what's happening, because we are trusted, we're not lobbyists, and we're not populist. We like facts and science. Most of our member societies aren't involved at all yet, but they're getting involved in the last 12 or 24 months. Presidents are looking for directions to what they should do, and they've requested slide decks and webinars, podcasts and other material to assist. So what we have done, last year, 2023, we ran 9 one-hour webinars given by world experts. Those webinars were well attended. They've all been published now in GUT, the Journal of the British Society of Gastroenterology. We're giving them slide decks, we're giving them information advocacy and talking to them about it. We've recommended, and they're doing it, that medical societies like GE Society has already done, like British Society has already done, like the American Society of Gastroenterology has already done, Canadians has already done, is to create a climate change committee, a group within your own society that will look at the facts, look at the data, and advocate and educate within your own country. Recommending that the medical societies hold sustainability sessions at each conference. This is one now at your conference, IFSO. But we at the GE Society have a sustainability session every year. World Gastroenterology Organisation, we've been having sustainability sessions every year since the first one I introduced in 2015. So this year's our 11th that we'll be having it in Marrakesh, Morocco. So you need to tell your own group, your own people, what's going on. And recommending that people create plans, and the society creates plans, for what to do personally, yourself, in your department, and in your country, and from there internationally. So the first thing is acknowledge that there's a problem, be committed to leadership, create sustainability teams, identify champions, and the champions are all amongst us. I mean, Chris is one of them. The champions are usually younger people than myself and others. They're usually people around Chris's age, or the senior registrars, or even the students. The people who've done a lot of reading, they understand what's going on, they've not been listening to lobbyists, but they're actually making their own decisions, and they can see that they need to take action. Creating agendas, personal agenda, what shall I do myself? What should I do in my rooms? What should I do in my university? What should we be doing nationally? Because people listen to doctors more so, they should, more so than opinion leaders. I say that with a slight cynicism in my voice. Educating staff, changing attitudes and behaviour, and working with industry. The 9 webinars we ran last year, one of them was with industry, the endoscopy industry, and they came and spoke to us about how we could work with the doctors to create better equipment and better endoscopes, etc., more cost-effectively produced and washed and cleaned, and what should we all be doing together. And the role disseminating information then to patients, because we all have patients and patients all have doctors, and to the community. Advocating for improved energy sources, more appropriate diet. I'm not quite a vegetarian yet, but I'm certainly, compared to where I was 10 years ago, I probably have about 1/10 the amount of meat that I used to have. But about once every 2 or 3 weeks, my wife and I will have some meat. Advocating for population control where possible. I mean, you can't actually go out and say to a group of people, you're not allowed to have children. But looking at the total picture, is it a good idea to have 12 children or 2 or 3 children, and spreading that suggestion through the community? Advocating for more efficient use of resources. Hugh talked about walking, electrical vehicles, train travel, cars, having 4 people in a car instead of 4 cars with 1 in each one. Reducing air travel until better sources of energy have been developed. I don't know if you all saw about 6 months ago, there's a company in Israel which has produced an aeroplane which is run totally on batteries, and it can go 200 kilometres on a battery. So this is the future. We will, I think, be able to fly again, but in the meantime, more research and more development will help us. And advocating for green endoscopy, which will be the subject of the next talk. So we can't wait for others to act. We all have a role to play. Suddenly stopping fossil fuel use isn't the answer. We have to transition from fossil fuels to solar, wind, water, hydrogen, and we also have to improve the infrastructure and storage. And where we're told by politicians that it's just too expensive, it's actually too expensive not to do these things. We're already seeing the insurance rising, we're already seeing the cost of fuels rising, and so the answer is, if you talk to economists, they're telling us we should be making these transitions now for the benefit of the economy. So educating, especially the younger people, giving them facts and refuting disinformation, empowerment of trainees and young people, creating champions, particularly the young, and doing more research. Now, this is an interesting paper that came out recently in JAMA in the USA. Medical schools which are teaching climate change in their curriculum. And 5 years ago, 27% of USA medical schools had climate change in the curriculum. It rose 2 years later to 55%, another year later to 65%. So the medical schools are realising that the young people want to know about it and they should know about it. So undeniable global warming has occurred. These systems are being adversely affected, including public health and our own well-being. And these are the simple things: food production, consumption, important determinants of sustainability, stop depleting natural resources, because they're relying on us to do this for long-term continuity of life on Earth as we know it. Stop using those things, increasing use of these things with a couple of question marks. Do it ourselves. If we say, where do we start? At home. Stop using the heating and put on more clothes. Stop using the cooling and open the windows. It's really interesting, but when we all go to conferences around the world, and we're used to going in the middle of winter in the USA, and they have the lecture theatre set at 72 degrees, which is 22 Celsius. And whenever I get there, having flown across the world, I fall asleep because it's too warm, it's too hot. They should have cooler, let the cool air in. And similarly, in the other end of the year, they overcool everything. Just let people understand that they don't have to have the room down to 20 degrees in the middle of summer when it's 35 outside. Hospital and institution, turning off the power, turning off computers, and using more seriously looking at the use of our equipment, and across the country and across the globe. Personal energy use, food production and use, transportation, forest destruction versus regrowth, water conservation, population control. Thank you very much.
Yeah, thanks, Chef.
Yeah, we'll go
Yep.
straight on to
Well-
the third talk, please.
Yep, but save your questions. We'll have a bit of discussion afterwards. Thank you.
Hello, I'm Daniel Schneider. I'm a gastroenterologist and interventional endoscopist from Melbourne, but currently at UCLH. I've been asked to speak about what every surgeon needs to incorporate into their practice. I have no disclosures, but would like to thank the organising committee for the invitation to speak. Just as a very brief recap, though, you've had an excellent talk from Professor Montgomery already. We obviously know that with climate change, we're seeing a rise in global air temperatures, as well as a rise in global sea temperatures, and we're starting to see the impacts of what this change in climate has in terms of severe weather events, which from Australia manifest in multiple ways, including drought, flood, and raging fires. We're seeing more extreme weather events more frequently, and the impact of these is substantial. So for reference, the top right map narrowed to Bairnsdale is a distance of about 600 kilometres. So to give you scale of how big these fires were 2 years ago, we're dealing with major catastrophes. We obviously know that there's more to climate change than extreme weather. In terms of its health adverse effects, we're seeing more respiratory disease, more cardiovascular disease. In affected areas, we're seeing rises of communicable diseases, which are avoidable in the setting of not having catastrophic climate events. And in the future, we're looking at the potential for forced migration and civil conflict, as well as heat-related illnesses. So, despite this very dire situation that we're facing, we obviously know the context and the risks that we're staring down, and we know that we need to act. But given that it is such a big problem, there is always a feeling of, well, what can I do as an individual? It's too big a problem and I'm too small. Fortunately, a lot of our societies from our gastrointestinal sphere have collated a lot of recommendations to try and break down the problem, to make it a much more individualised, yes, you can help and at what level perspective. And that's something that we'd like to talk about today. So the British Society, the American Society, and the European Society of Gastroenterology and Endoscopy have provided guidelines that help us break down this big problem. The ESG guidelines make 39 recommendations, which I'd like to touch on today, some in very light detail, but ultimately all pooling towards achieving green endoscopy. So the aims of this guideline was to raise the awareness of the ecological footprint of gastrointestinal endoscopy, which is poorly understood by many, as well as then to provide guidance on how to reduce its environmental impact. In terms of the environmental impact of healthcare, we need to think more than just the waste that we generate, but we also need to think about air, land, and water pollution, knowing that about 4 to 6% of all greenhouse gas emissions are due to healthcare. And in the United States, that figure is about 8%. In terms of healthcare's greenhouse gas emissions, we've seen over this century that they're rising, and from about 2000, they've risen around a third already, so it's something that we need to act on. In terms of the environmental impact of GI endoscopy, it's hard to quantify, but needs obviously more research to tease out the different components in terms of the waste associated with accessories, medications, and then other miscellaneous things such as travel needs and the endoscopes that we use. It's been attempted to be assessed in a systematic review, but with only 6 studies, it shows that there's really more of a need for research. What we do know, however, is that as a waste generator, that endoscopy is either the second or third highest waste generating procedure in medicine. It accounts for about 2 kilograms of waste per procedure, and a recent US study showed that only 9% of this was recycled. In terms of carbon dioxide emissions, it's estimated that about 5 kilograms of carbon dioxide is generated per endoscopic procedure. And even thinking about the biopsies we use, they have their own separate cost, with nearly a third of a kilogram of carbon dioxide per biopsy. So if you're doing a moderately busy list of 10 endoscopic procedures and taking 1 biopsy per procedure, all of a sudden you've generated 55 kilos of CO2, which I think is a much higher number than any of us would appreciate first up. So then in terms of thinking about the aims of the position statement, we also want to think about ways in which we can then reduce our environmental impact. So we want to try and achieve green endoscopy, and in the operating theatre, obviously green theatres as well, which we'll talk about later. But in terms of endoscopy, it's got a few components where we think we can change simple things that have a big impact cumulatively. The most important cornerstone of all this, which I want you to all remember, is that the most wasteful procedure is the one that didn't need to be done in the first place. Given the amount of waste that we generate with endoscopy, with procedures, we need to think about really making sure that we're doing them at the right time for the right patient. So that really comes down to making sure that we have an appropriate indication for endoscopy. 2 recent meta-analyses that covered about 75,000 patients showed that the rate of inappropriate endoscopy in these studies was almost 30%. But conversely, they did show that for the adequately indicated endoscopy, the yield of what was found was actually much higher. So an extra reason to reinforce that we should only be doing appropriately indicated endoscopy. We need to think that over-surveillance is something, obviously, that has been shown to be commonplace, and we need to think about where that might be happening and how to improve that. Some areas are going to be very well outlined in terms of guidelines that can be followed, and they are constantly changing, and they do vary from country to country. So the colorectal polyp guidelines have probably changed multiple times since when you've gone through your training. So it is relevant to stay up to date on that front. And we do know that there is some slight variability between countries, but ultimately a lot of over-surveillance happens in this area, and it's something that's very easily fixed. Other areas are a bit more difficult. So we know that, say, in the bariatric setting of post-bariatric surgery, Barrett surveillance, there's no excellent consensus guidelines yet, but there's a lot of discussion and research about what should be done. Obviously, we need to keep an eye out for when that arrives, but we need to be mindful in the meantime, until we have great guidelines to follow, that we just need to think about the patient in front of us and think about whether we need to be doing the scope on them at this point in time. In terms of then thinking about things that don't need surveillance, obviously when we do endoscopy we sometimes find things that we weren't expecting, but it's very clear that some of these things we can confidently diagnose and then know that they don't need surveillance. So in the esophagus, things like an inlet patch, doesn't need to be surveyed. Likewise, in the stomach, things like fundic gland polyps, if you're confident that's what the diagnosis is, leave it alone, doesn't need to be surveyed. In terms of subepithelial lesions, once we know someone has a leiomyoma or a lipoma, that doesn't need ongoing surveillance. Likewise, if you are confident that you're seeing a pancreatic rest, that doesn't need an on-referral for an EUS, which obviously will generate more waste itself. In the duodenum, duodenal ulcers are completely different to gastric ulcers in that we know gastric ulcers require malignancy surveillance in 6 to 8 weeks. A duodenal ulcer does not need any surveillance. And in the pancreas, if you've diagnosed a serous cystic neoplasm, it's a benign lesion and it doesn't need to be followed up. We can also think about less invasive alternatives to endoscopy where appropriate. So screening can be done with a fecal occult blood test very effectively. Likewise, if you want to rule out H. pylori, urea breath test is a great test off a PPI. chronic diarrhea, a good first up test is a fecal calprotectin to then help you decide whether you want to go down the endoscopy path. We also need to think about the medications that we're using. So we want to avoid unnecessary antibiotics for a number of reasons, but also the waste generated. We know that the guidelines have shifted. From my own practice of ERCP, the guidelines from both the Americans and the Europeans now suggest that we don't need to use routine antibiotics for ERCP unless there's concerns about inadequate drainage or you're using cholangioscopy or there's a patient-related factor. In terms of routine IV fluids, that's probably best done as a case-by-case thing rather than everybody gets them. And I think that's really important now when we're thinking about the global shortage of intravenous fluids as well, not just from a waste perspective. We also want to think about non-indicated PPI use and cutting that down. That's probably one of the most common questions I get from patients about length of PPI, and I think we've seen recent American data reassuring us that they're safe long-term, but they should only be used long-term if they're indicated. If they're not indicated, cease them. And then I think it's reasonable to have a shared decision-making discussion with anaesthetic colleagues, which can be really open and not treading on their toes. But I think if you're doing a quick gastroscopy, it's entirely reasonable to think that an anaesthetist can do that with hand infusing with a syringe rather than needing to set up an infusion machine and all the ancillary equipment required with that, with its waste as well. We also need to think about the way that we perform our biopsies, so being really targeted with what we do to reduce waste. In terms of things that either don't need biopsies or you can rationalise the way in which you biopsy, so from a regular Z-line perspective, if you're confident that there's no IM there and that there's no dysplasia, you don't need to biopsy it. It's just an irregular Z-line. Candida, only really if it's going to have antimicrobial consequences in terms of what choice is used, then you don't need to biopsy. You can just make a visual diagnosis and treat. In terms of excluding celiac disease, if it's someone who doesn't have celiac and you just want to rule it out for mild iron deficiency, it's entirely reasonable if it looks macroscopically normal to put all your D1 and D2 biopsies in one pot and reduce waste that way. From a colonoscopy perspective, for those of you who do colonoscopy, in terms of dysplasia surveillance in IBD, it's appropriate to use narrowband imaging rather than dye spray to look for dysplasia, and it's equally reasonable to do targeted biopsies rather than just randomly biopsying and using lots and lots of pots. In terms of endoscopically resectable lesions, I would say please don't biopsy if you're confident that it's not malignant and needs an operation. If it can be removed endoscopically, we know that it's actually more difficult to remove if there's fibrosis that's happened as a result of biopsying. If you're confident with the diagnosis and you know that you're not the right person to remove the lesion, don't biopsy it. Just photo document well and then refer on. In terms of hyperplastic polyps in the rectosigmoid that are small, you obviously know that they don't need to come out, so it's not worth it. And then in terms of excluding microscopic colitis, you can use the same pot for the right and left biopsy. In terms of then rationalising the use of techniques and accessories, we want to make sure we're using the right thing. So there are obviously multiple techniques to remove things like polyps. These are obviously diminutive flat polyps, but can be done either with a cold snare or with a lift, although some people would still use a hot snare, which we would hope they don't. We know that cold snares are greener in terms of using less electricity. Doing a cold snare polypectomy obviously doesn't require the equipment of an EMR, and they're safe in terms of reducing perforation risk as well as bleeding risk. This recent study showed that for colorectal polyps less than 20 millimeters, that doing cold snare polypectomy versus cold snare EMR actually had the same amount of, or rather had no statistical difference in terms of outcomes in terms of complete resection or adverse events. And the statistically significant finding was that doing an EMR added more time. What is also clear is that it also adds more equipment that is unnecessary, and so if you want to make a saving there, both in terms of cost as well as from a sustainability perspective, use the alternative, which is more straightforward. Likewise, the guidelines, just to recap, suggests from the Europeans, and these have been updated in 2022, I might add, that any polyp less than a centimetre they're recommending being removed with a cold snare. So if your current practice is to do that with a hot snare, please consider using cold snare instead because of energy savings, equipment savings, and safety for the patient. In terms of other equipment we can use, there are obviously multiple techniques. So if you want to do an esophageal dilatation, you can use a balloon or a bougie or even a cap. But we know that using a balloon is a single-use item. It generates almost 0.5 kilogram of waste that's going to go straight in the bin, compared to a bougie dilatation that will be disinfected, no extra plastic weight, and can be used for up to 10 years. From a technique, personal preference, I would go a bougie almost all times because I think you get more faithful feel and you know that you're actually going to deliver that diameter. Sometimes you get wasting on the balloon with a balloon dilatation, but each to their own on that front. In terms of the takeaway messages then from equipment use, we want to use the less resource intensive technique. We want to reuse accessories if we can, and also a word on clipping polyp defects. They should only be done if there's concerns about bleeding, either at the time or a very high risk of rebleeding lesion, or likewise concerns about the depth of injury or risk of perforation. In terms of the logistics of endoscopy, we want to think that this is a multifactorial thing. We need to think about building, cooling and heating, digitalisation and waste management. We know that 1 degree of heating in the building can increase energy consumption by 10%, so that can actually have a huge impact. In terms of segregating waste, a recent survey showed that there was a high rate of inadequate waste disposal and less than 1% understood disposal costs, and almost everybody felt that more education and information was required. So there are multiple ways to dispose of waste, and it's really important that the appropriate waste is going in the appropriate bin, and really trying to maximise the amount of recycling that can be done from all the packaging that we go through. A recent study from Oxford looked at diverting waste from landfill and incineration to recycling, and it showed that it saved money and carbon. The cost of disposing of waste that needs to be dealt with medically is much higher than just general waste, and likewise that of recycling. So showing that we can actually save costs as well as carbon dioxide is a really important thing to remember, and I think once that gets shown to hospital administrators, that's definitely cause for change. In terms of single-use products, always a vexed issue. We always need to balance the benefit of patient safety in really rare situations against the economic cost, environmental and societal costs as well. Infection needs to be as low as reasonably practical, but we also need to balance the waste that's generated. So single-use endoscopes obviously have a high price, but also increase the net waste by about 40%, with a single duodenoscope generating about 30 kilograms of carbon dioxide, which is about 20 times more than a reusable duodenoscope. And this is a breakdown of the sort of carbon inputs and waste generation, as it were, of a single-use duodenoscope in terms of carbon emissions on the right, and you can see that the biggest factor there that makes it such a standout CO2 generating device is the entire manufacturing, which has to be done every time. In terms of green quality, we need to think that sustainability is a domain of quality GI endoscopy. And then in terms of the realm of research, that's something that we need to grow. This is a study looking at new sustainable equipment. This is a study that we did at UCH that looks at a biodegradable pancreatic stent rather than a plastic stent. And with our cross-site study, we showed that the excess footprint of using a plastic stent in terms of carbon dioxide was 18 kilograms per procedure. And with all the patients who had plastic stents put in, that generated well over a ton of carbon dioxide. So as new devices come in that are more sustainable and provide more sustainable practice, we need to think about incorporating them. We also showed in a separate study that the actual cost difference was pretty similar, and with change in market forces over time, hopefully this becomes even more attractive. From conferences, we need to think about what we do from a sustainability perspective. This is the recent ESGE conference, and rather than expensive plastic chairs, They had cardboard boxes that you could sit on and could then be recycled, which was a great initiative. Other conferences need to take the lead in terms of what we do for sustainability and think about, reducing the amount of printed materials, not providing meeting bags, things that just ultimately go in the bin, let's be honest. In terms of advocacy, this is where we can also step in. So we want to talk to industry, governments, patients, healthcare providers and policy makers about how we can go green in the theatre, in the endoscopy space. From a local level, this was our work at the Royal Melbourne, where our working groups from each different aspect of the hospital would then feed into a clinical sustainability working group that then would feed up the chain to the board and the executive. So ultimately, we know in terms of actions that there are high risks. We know what the context is. We know that we need to act, but I hope that I've empowered you to think that you can do something on an individual level. And what is that? That is being the eco-endoscopist, the eco-surgeon, thinking about the ways that you can manage your waste, the way that you approach procedures, only doing procedures that are indicated. But it also extends beyond this to think about using renewable energy in hospitals, procurement, purchasing, thinking about doing that in a sustainable manner, and being champions of sustainability. In an operating space, obviously, this has been widely published by the College of Surgeons in England as a guide to good practice in sustainability. They've also generated an intercollegiate green theatre checklist to try and help in that manner. But ultimately, we want to get down to the fundamentals of reducing, reusing and recycling so that we can maximise sustainability, enable improvement, develop collaboration and minimise waste. With my last take-home message of being the most wasteful procedure is one that didn't need to be done in the first place. Thanks for your time.